Mastermind presents. Today we are gonna start our new chapter, that is number system of class 9, and here is its introduction. This is the line that we all have seen in our junior classes. Let's see them in deeply. The number here you see are the natural numbers which start from 1 to infinity, and when we can add 0 to them, not these, only 0 to infinity are known as our whole numbers. When we add the negative numbers, that -1, -2, -3, then this whole line is called the integers. Okay, here you can also see them. These are our integers. When we add these negative numbers, for example, here is 0 and here is infinity. Here is 0 and here is infinity number, that is the positive side, and here is same of the negative side, and there are also the fractional number like 1/4, 2/5, 3/7, and so on. Then they are called rational numbers. Now let's see. Here we have 1. Can we not consider it in the rational number? Why not? We consider them. Here is 1. Can we can't see them like this? Here it is 2. We can write it as 2/1 and 3/1, and even even 0 also, like 0/1, -1, -1. Okay, in this way we can represent them, and here that is why we consider all the numbers that are mentioned in this number line, figure 1.1. We consider them as the rational numbers. If we deducted the rational numbers, that means we are left with the integers, like there is only -3, -2, -1, 0, 1, 2, 3, 4, not the fractional numbers. Okay, and here they just tell us same thing. Here in this slide they carry the natural numbers, that you can see there is no any negative number. Okay, and when we add the 0, that becomes the whole number. Okay, and in their counts we put the negative numbers also, that come to be integers. Okay, and now we put the rational number. Rational number, whether it is positive or whether it is negative, these are rational numbers. Okay, here you can see the collection of Q. Okay, here we denote it with Q because it is a quotient, and we always write in this form P/Q, as all the rational numbers written in the form of P/Q. Okay, where P and Q is equal to integers. What are the integers? We already learned that all the numbers which are not in fractional, like this one. Okay, here Q is not equal to 0, and here one thing more, P is also equal to 0, and we can't write it as 0/1. This is also a rational number. Okay. For example, minus 25 can be written as minus 25 over 1. That is why we call negative number also a rational number. Okay. And here you can see that I take randomly a fraction that is 1 over 2. Okay. Now multiply it with 2. It becomes 2 over 4. Okay, so I can write it as 1 over 2 equal to 2 over 4, and same 1 over 2 into 3. It will be 3 1 3 2 6. Why I can write them so? Because when I cut it, like 2 of at the table of 2, they will become same number 1 over 2, 1 over 2 and 1 over 2. Okay. The same thing is written here, which I have just explained you. These are known as equivalent rational number, equivalent rational number, or fractions. Okay, equivalent rational numbers or equivalent fractions. Okay. And even we can take the another examples also, like 3 over 5, 2 over 6. Means you can take any of the examples. Okay. Now let's solve our example 1. That is true or false. Okay. We have to write true or false. Every whole number is a natural number. We know that in a whole number, the only things that contain are these, and in natural number, these contain only these. Okay, so I can consider the 1, 2, 3 and so on numbers in the natural numbers, but can I consider the 0 as well? Can I consider 0 as natural number? Definitely no. So that is why our first is false. Okay. So here we write our answers. First is false. Now let's begin to the second one. Every integer is a rational number. Definitely true, because we can consider all the integer into the rational number, like 0 over 1, 10 over 1, minus 10 over 1, and so on. Every rational number is an irrational number. Wait for a while. Every rational number is an integer. No. Let me explain you. Every rational number is an integer. We know that every integer is a rational number. Every integer is equal to rational number, but not all rational number are integers. For example, minus 2 over 5. This is not a rational, or this is not our integer. Even we take the minus 24 over 27, which is a rational number but not an integer. we can also take it in positive. Okay, now let's begin with our second example. Here we have to find the 5 rational number between 1 and 2, and there are 2 ways to do this method. Let me tell you. In the first way, you can add the r plus s over 2. Let me example. We have to find the rational number with 1 and 2. Okay, here we will do the sum 1 and 2. Okay, 1 and 2. Here, let the 1 equal to r and 2 equal to s, which will become 1 plus 2 over 2, that is 3 over 2. Here we find our first integer between 1 and 2, that is 3 over 2. 3 over 2. Now let's find another. Now we have know that 1, 3 over 2, 2, and we have to find another number here. Okay, for this we have to add 3 over 2 plus 2. It will become 2. Here we take the LCM, it will 3 and it will become 4, that is 7 over 2. Here it's 2 and it will come to below, which will become 7 over 4. And here is our another integer as well. That is 7 over 4. And in this way, we can find our another integer. Like he find 5 over 4, 11 over 8, 13 over 8, 7 over 4. Okay. Now the second method is. In the second method, he will take the, like I have to find the numbers between 1 and 2. Also, we have to find the 5 rational numbers between 1 and 2. So he take 5 plus 1. And same here, 5 plus 1. Because they both get cancelled, so this doesn't take any matter. Okay, it will become 6 over 6. 6 over 6, and it will become 2 into 6 over 6, that will 12 over 6. Wait. Over 6 and 12 over 6. Here we can find a number of numbers like 7 over 6, 8 over 6, 9 over 6, 10 over 6, 11 over 6, and 12 over 6. These are the two numbers, is 6 over 6 and 12 over, and these are our 5 rational numbers. Okay, now we can cut 2 4 the 8, 2 3 the 6, 3 3 the 9, 3 2 the 6, 2 5 the 10, 2 3 the 6. Okay, that here we come with 7/6, 8/6, 9/6, 10/6, and 11/6, which currently come this numbers. Okay. Now there is remark that there are infinity rational number between any two given rational number. Means there are infinity, there are numerous number. Maybe your answer get different from me, because there are infinite number, and I have found a little bit of them. So this line is very important. Okay. Now let's move on. And there are some questions that are left, which we will do in our exercise 1.2. Okay. Let's begin with our exercise 1.1. Is 0 a rational number? Can we write as P over Q and P over Q, where R integer and Q is not equal to 0? That possible? We will tell this, as I tell this in the introduction of the chapter, that 0, we can write this 0 as a rational number, 0 over 1. Here we can write in this in the P over Q form, where Q is not equal to 0. So 0 over 1 is our rational number, which is the answer of our first question, 0 over 1. Now we have to find the sixth rational number between 3 and 4. Okay. Now let me tell you, there are many ways. As I told you, 3 over 4. There are two ways. I'm doing it in the first way. No. Okay, I'm doing with the first way, that is 3 plus 4 over 2, that is 7 over 2. And here I found a single number. In this method you can find the another number also. Okay. Now the next question is 3 over 5 and 4 over 5. I'm doing this method with the second method so that you can able to understand both the methods. Here we have find the 5 numbers, so we multiplied it with 6, with 5 plus 1. Okay. Here will 3 6 85 6 30. Let's carry on. Here we have number 18 and here is 24, which will become 90 over 30, 20 over 30, and so on. Okay, here we can find this in 23 over 30 with the same method. Okay. Okay, we have write this answer. This its answer is 0 over 1, and the answer I found a single. Okay, you have to solve them in your own way. Okay, now we will do the true false, that is our fourth part, and all. This part is very important, as these are some tricky questions that usually use. Okay, every natural number is a whole number. Yes, because the natural number starts from 1 over 2, 1, 2, 3, and so on. Okay, and the whole number starts from 0. So all the set of natural number is contained in the whole number. So that is why it is true. Every integer is a whole number. It's wrong, because our number lines like this, -1, 0, 1, 2, 3, 4, and so on. Okay, every integer is a whole number. All the integers are the whole number. That's not possible because we have -1, which is not considered in this set of the whole number. That is why this is false. Every rational number is a whole number. Now we also discussed it earlier, like 4 or 5. It is not considered in the whole number. That is why it is false. So guys, here we end. In this we have discussed the exercise 1.1 and the introduction of our first chapter, that is number system. For the coming video, we will discuss the 1.2 exercise. Till then, bye bye. Thanks for watching.